Good morning, Morgan.
Morning.
How are you today?
Good, how are you?
Good. Okay, where do you want to start here?
You could just start at the top, so 46.
That function one-to-one?
Mm-hmm.
Okay, one-to-one means that not only, for something to be a function, it has to pass the vertical line test. For a function to be one-to-one, it has to pass the horizontal line test.
Okay.
In other words, it has to pass horizontal and vertical. And this does not pass the horizontal line test. If I draw a horizontal line through there, I pass through the function twice.
Mm-hmm.
Okay? Something that would be one-to-one would be this. Notice that's y equal x cubed and passes the vertical line test
Mm-hmm.
and also passes the horizontal line test. No matter where I draw a horizontal line, I only encounter the function once.
Okay.
Okay? And only one-to-one functions have an inverse. That's the importance of a one-to-one function.
Okay.
Well, only one-to-one functions, inverses are functions. Let me put it that way.
Uh-huh.
Okay, what kind of transformation is this?
Let me look at my notes. Is it horizontal, or no, vertical?
No, it's horizontal.
Oh,
Here's
yeah, horizontal.
here's the thing. If f of x equals x squared, what this really is f of x plus 8.
Mm-hmm.
And it's supposed to be x minus h. So anything that is h is a move, a positive h is a move to the right. But this actually would be a negative h. In other words, h would have to be negative 8 in order to get that. So this is a move to the left.
Okay.
Okay? Now let's say you forgot whether it's x minus h or x plus h. By looking at this function, what value is going to make y 0?
8? Or
Well,
I mean, negative 8?
negative 8. So the vertex has to be over here at minus 8. In other words, that's the place it's going to be 0. So by looking at the problem that way, you can figure out that, well, this is a horizontal move to the left of 8 units. Even though it says plus 8, it's because we're looking for x minus h.
Okay. So it's like the opposite.
Yes. Most of these are going to be x minus h, as you'll notice. For probably the rest of your math life, it's always going to be x minus h, not x plus h. So get used to x minus h. Okay? So on 48, what is the consequences of the negative 4?
Do you move right 4?
Yes, because it's x minus h. So h would be positive 4, and positive means move to the right. What's the consequences of the plus 19?
Do you move up 19?
Yes, vertical shift, because
Okay.
this is not, what this is f of x minus h, but then it's plus 19 afterwards. The plus 19 does not figure into the f of x. It's merely added, and that is a vertical shift when that happens.
Okay.
So this one would be 4 to the right, up 19, be somewhere up there.
Okay.
Okay, here they want to transform the graph of f into g. Well, let's draw f. Square root function starts right there and goes up like that. So that's y equals square root of x. Okay, now when you're talking translations and shifts and stretches and reflections, there are 6 things. You can horizontally translate right or left. That's 2 things. You can vertically shift up or down. That's 2 more things. It's actually 10 things, because you can stretch vertically or shrink vertically. That's 2 more things. You can stretch horizontally or shrink horizontally. That's 2 more things. So that's 8. And then the last 2 things you can do is reflect across the axes, either the x-axis or the y-axis. So do you know all 8 of these or all 10 of these pretty good?
Not really. We just learned this a few days ago, so.
Okay, well, let's talk about this. If I wanted to plot y equal negative square root of x, what would the effect of this negative sign be?
Would it stretch?
No, think of some numbers. If x is 16, this is going to be 4. Well, if x is 16 down here, what is this answer going to be?
Negative 16?
Negative 4.
Right.
Because it's the square root of 16.
Right.
So this negative sign merely changes whatever y value we were going to have and makes it negative. So that is a reflection across which axis?
Vertical? Or the y?
The horizontal axis.
Oh.
Notice that if I plot this, this is y equal negative square root of x. Whatever I got for the square root of x, no matter what x was, if it was here, well, I'm going to do the negative of it. So it's going to be there. If it was here, I'm going to do the negative of it. It's going to be there. So it's a mirror reflection across the x-axis when you stick that negative sign out in front. Okay? Same thing with y equal x squared looks like this, but y equal negative x squared looks like this. So this leading negative sign in front of the function, notice that this is minus f of x. It is not f of minus x. If the negative sign is inside the function, it's a reflection across the y-axis, and we'll get to that later. But that's the 2 kind of reflections you can have. If the negative sign is outside the function, like it is here, by the function I mean f of x,
Mm-hmm.
then it's a reflection across the x-axis. If it's inside the function, it's a reflection across the y-axis. All right, let's look at one that would be a reflection across the y-axis before we go into more of these problems.
Yeah.
Let's take that same square root function. Okay, that's y equals square root of x, or I could say that's f of x equals square root of x. Well, what would f of minus x be? That would be the square root of minus x.
Mm-hmm.
Notice the difference. Here the negative sign is inside the function.
Yeah.
This is a reflection across the y-axis.
Uh-huh. Okay.
In other words, x's all have to be negative is the only way you can even have the square root of negative x.
Mm-hmm.
So if x is minus 16, y is 4. So over here, when x is 16, y is 4. Well, over here, when x is minus 16, y is plus 4. So it makes it a reflection across the y-axis.
Mm-hmm.
Okay? This concept of figuring out whether your negative sign is inside or outside the function is important. Here's a particularly difficult one. E to the x. Familiar with this function?
Yeah.
Okay, so that's saying f of x is e to the x. Well, f of minus x, since the minus sign is inside the function, should be a reflection across the y-axis. Well, what is f of minus x equal to?
Isn't it just EX?
Always plug in whatever's inside the parentheses for x. So it would be e to the minus x.
Okay.
Okay? So, if I said, what's the relationship between e to the minus x and e to the x, you know that e to the minus x is a reflection across the y-axis.
Right, because it's with X.
There's e to the minus x.
Mm-hmm.
And that's as hard as you'll come across, most likely,
Okay.
in terms of difficulty determining whether it's a reflection across the x-axis or the y-axis. That's the hardest part about translations. Okay, so let's look at 49. Remember that that's f of x.
Mm-hmm.
So what do I do to get this? What's the consequences of that plus 6?
Do you move left 6?
Okay, so if I didn't have this negative sign, if I had just square root of x plus 6, it would look like this.
Mm-hmm.
What's the consequences of the negative sign?
It's a reflection, a horizontal reflection.
Say which axis.
Oh, over the x-axis.
Okay, because I'm not sure what a horizontal reflection means. Okay, yes I do. Now I get why you said that. Okay, so it is reflected horizontally instead of vertically.
Mm-hmm.
Okay, so that's how we transform that. Now, the order of transformations is kind of important. Always do your reflections first.
Okay.
If you do the horizontal translation before a reflection, you can end up with the wrong graph. So if you're doing both horizontal and reflections and vertical, make sure you do the reflections first. As long as you do any reflections first, I believe that solves the problem. In this particular case, I didn't follow my own rules. We should have done the reflection first. But notice it didn't matter here. In other words, if I do the reflection first, now the shift, I get the same thing we got. But had this been a vertical reflection instead of a horizontal reflection, it would have mattered. So sometimes when you get both, it really does matter which you do first.
Okay.
So what is this? In other words, this is if f of x is equal to x to the fifth, what we're really doing is taking f of 6x, right? Well, notice that this 6 is inside the function. We're not taking, we didn't do this. Excuse me. We didn't do that.
Right.
If this is inside the function, it represents a horizontal shrink if it's greater than 1. If it's outside the function, it represents a vertical stretch if it's greater than 1. In other words, let's talk about vertical stretches. They're a little easier to see. If I had y equals square root of x, and I say, okay, well, draw for me 3 times f of x, which would be 3 square roots of x. Well, this 3 acts, because it's greater than 1, it acts as a vertical stretcher. In other words, every point that would have been there is 3 times higher. So if a point would have been there, it's way up there. So this has the effect of that. That would be a vertical stretch. Okay? If the constant is inside the function like this, it acts as a horizontal shrink. Not a horizontal stretch, but a horizontal shrink. So whatever x to the fifth looked like, let's take an easier one. Let's for the moment. Let's say f of x is x cubed. Well, if I plot x cubed, looks something like that. And if I said, well, what is 2x cubed? By a 2, I mean there. That's going to be a vertical stretch because that's the same as 2 times f of x. So that would have the effect of making it narrower and skinnier because that would be a vertical stretch. Okay, but if I said, well, what is f of 2x? This 2 now being a horizontal shrink, because when you're talking horizontal stretches, horizontal shrinks happen when this number is greater than 1. Horizontal stretches happen when this number is between 0 and 1. So if I said the quantity 2x cubed, that 2 represents a shrink by a significant factor. Well, what is a horizontal shrink? It's kind of the same as a vertical stretch. Because if I were to multiply this out, that's actually 8x cubed. So a horizontal shrink by a factor of 2 in this case is the same as a vertical stretch by a factor of 8.
Okay.
Okay? So that's vertical stretches and shrinks as opposed to vertical shifts and horizontal shifts. So when I say what is 6x to the fifth, well, that's the same as f of 6x. So what are we looking at here? What is this relative to this?
Is it a horizontal shrink?
Yes, by a factor of 6.
Okay.
And do they want that? Let's see. Yeah, horizontal shrink by a factor of 6.
Mm-hmm. Okay.
That factor of 6, I'm a little
Yeah, I
not
have the answers.
100% sure on that because, well, notice that a horizontal shrink by a factor of 6 is the same as a vertical stretch by a factor of 6 to the 5th power.
Yeah.
So they're not apples and oranges. In other words, they are apples and oranges. You can't say that a horizontal shrink by a factor of 6 is the same as a vertical stretch by a factor of 6. It is not.
I have the answers, and it says a horizontal shrink by a factor of 1/6.
Well, okay. When I say a horizontal shrink by a factor of 6, I mean 1/6.
Oh, okay.
In other words, what I took was our x cubed. In other words, when we were plotting x cubed, and I shrunk that, it got like this. Okay? So you're correct. It really is more appropriate to say it's a shrink by 1/6.
Okay.
Or a factor of 1/6. I guess it is a shrink by a factor of 1/6. You're right. It's more correct to say it's a shrink by a factor of 1/6 than it is to say it's a shrink by a factor of 6. Shrink by a factor of 6 doesn't really make any sense because when you say a factor of 6, that sounds like a stretch.
Uh-huh.
So to shrink something, it does have to be a number between 0 and 1. So
Okay.
my apologies. That is a shrink by a factor of 1/6.
Do you think we could just do like a few more of those? Like you could just make up a few problems? Because I
Sure.
just want to get it down.
Definitely can. Although we're not done. We got a lot of these to do.
Yeah.
Should we go through
Or yeah,
these?
maybe we can go like 53.
Let's go
is
over
coming.
51 and 52. And yeah, we'll get all of this covered.
Okay.
Well, that's all right. Let me make up one more here that I can think of very quickly. If f of x is equal to x squared, it's a parabola. Tell me what y equals is.
So is it a horizontal shrink of, I just don't understand what factor it would be by.
Well, the other one was the reciprocal of 6.
So it'd be 4?
Yeah, this is a horizontal shrink by a factor of 4, which means hold on a second. Which means this is flatter. Notice that this is the same as 1/16 x squared. Well, we know that would be the vertical stretch or shrink factor. So 1/16 x squared would be a vertical shrink of 1/16. So that makes sense with this. This is a horizontal shrink by a factor of 4. I suppose you could say it's a horizontal stretch by a factor of 1/4. What does your book say? Oh, I made this up. Well, maybe we'll get to fractions later here.
Yeah.
As long as you know what the curve is doing, I don't think it's as important to know what the words are. In other words,
Yeah.
shrink
Okay.
by a factor of 1/6 or shrink by a factor of 6 kind of mean the same thing. So the words can be manipulated. What's really important is you know what the graph does. Does the
Mhm.
graph flatten or does the graph get narrow? Well, I know that 2x squared, the graph gets narrow. So that is a vertical stretch.
Right.
But 1/2 x squared, the graph gets flatter, so that's a vertical shrink. A lot of these can be viewed somewhat the same way as either a vertical stretch or shrink. Let's look at 51. There, let me. So here, and I think it actually is quite effective to call these f of x instead of y.
Mhm.
Okay. You'll notice that this is some sort of a modification of y equal x cubed.
Mhm.
And it says by vertically reflecting about which axis?
Why?
Now remember, this negative sign is out in front. It's not
Oh,
inside the function. It's out front of the function.
Mhm.
So
So it's
that
X.
means it's x.
Okay.
In other words, whatever this number would be, we're going to make it negative instead. So it's a vertical reflection across the x-axis, and notice they did that first. And
Mhm.
then after the reflection, we're going to shift it vertically by how many units and in which direction?
Right.
Vertically.
Or oh. Um. Is it? I don't know.
Hold on, did I
Is
miss
it
some words?
positive or negative?
Ah, okay, I missed some words here. I thought I was missing some words here. Let's go back for a moment. By vertically stretching by a factor of what?
Um. Is it 1/8?
No, this makes this thing, it's a factor of 8.
Okay.
Okay, because that 8, in other words, y equals x cubed differs from y equal 8x cubed merely because you've stuck an 8 in front of the function. So if my function, let's eliminate the 3 for the moment. Let's take away that for a moment. When I look at y equal 8x cubed, that is a vertical stretch by a factor of 8. Why? Because this is 8 times f of x. That's a vertical stretch factor.
Mhm.
In other words, it's not f of 8x. It's 8f of x. You see the difference?
Yeah.
If this number is in front, in other words, if we're looking at something that is some number times f of x, it's a vertical stretch or shrink. So that's the
Okay.
first thing we know, is we have a vertical stretch by a factor of 8. Then when you look at the negative sign, it's reflected about the x-axis,
Mhm.
and then it's shifted vertically. How many units? Because of this part here, which is also being added to f of x. It's not inside.
So it's 3 units to the right.
Up. Vertically it has to be either up or down. Horizontally it
Okay.
has to be either left or right.
Oh.
Vertically can't be right or left. Vertically is
Oh,
going to
so
have to be
up.
either up or down. Okay, and it's up because of the plus sign.
Yeah.
So let's kind of try to draw this just to see what we would get. If here is y equal x cubed, there's your elementary function. Okay, we're going to do, doesn't matter if I do the negative or the stretch first. I can do either one of these. The order doesn't matter. It's probably a little easier to see if we do the vertical stretch first. Well, by a factor of 8 is quite a bit. In other words, every one of these points on this curve is going to be 8 times higher. So it's going to have the effect of making this look more like a vertical line than a curved line. Okay? Because this point here would be 8 times higher. It would be way up here. Okay, now let's apply the negative sign, because we definitely want to apply the reflection before we do any vertical shifting. So if I reflect this dotted line across the x-axis, it becomes this. Okay, so now this is y equals minus 8x cubed, and now I'm going to move this curve up 3 units, so its cross point is now going to be at 3, and it's going to look like this. If you can see that, maybe if I draw that in a solid line. So that's exactly how you do it.
Okay.
All right, let's look at 52. Did you have answers on that?
Oh, yeah, I can check.
Make sure we get our terminology correct here. It should be vertically stretching by a factor of 8.
Yeah.
Okay. And reflected across the x-axis and shifted vertically plus 3 units up.
Yes.
Okay. Let's look at 52. Okay. 52 is a little bit unusual in that it is not a function that we're that familiar with. It's the cube root function. So first of all, let's write out what f of x is and then try to figure out what this is. Well, what's our elementary function that we're dealing with here? Let's call that g of x.
Oh, is it like the cube root of x? Yeah.
Correct. Okay. The cube root of x is the inverse of the cubic function. So the cube root of x, let's see here, when x is negative, y is negative, so it looks something like this. There's that function. In other words, when x is 8, y is 2. When x is negative 8, y is negative 2.
Okay.
So its domain is all real numbers. Don't have to have positive numbers because you can take the square root of negative, you can take the cube root of negative numbers. As long as this is an odd root, then your domain is not restricted. Okay, so let's see. We agreed that we should do reflections before we do anything else. So what's the first thing we should do here? is this reflection inside the function or outside the function?
Inside?
No, inside would be if it was a negative in front of the x, then that would be inside this function. That's what I mean by inside or outside.
Okay.
In other words, this function, the elementary function we're dealing with here is cube root, this plus 4 is inside the function, but this 3/4 and the negative sign are outside the function.
Oh, yeah.
In other words, f of x is equal to negative 3/4 of g of x plus 4. Plus 4, it goes inside the function. In other words, the plus 4 is inside the function, but the negative 3/4 is outside the function. So first thing we'll do is reflect. Well, when we reflect, when it's outside the function, you're reflecting across the x-axis. So this line would be h of x equals negative cube root of x. Okay? Now let's apply the vertical stretch or shrink factor, which is what?
Is it stretch?
Well, it's a shrink because it's less than 1.
Oh.
Now, horizontally, a shrink is when it's greater than 1. So they're the opposite. So know that.
Okay.
This 3/4 is outside the function. It's not inside the function. That makes it vertical in nature. And since it's between 0 and 1, it is a shrink, not a stretch. Which means every point that would have been here, it's now only going to be 3/4 of the way it would be there. So when I draw this curve, that is now negative 3/4 cube root of x, right?
Yeah.
One last thing to do. What is it? How do we handle this plus 4?
We subtract it or move to the left?
Move it to the left, exactly, because we're looking for x minus h. Therefore, 4 must be negative 4. I mean, h must be negative 4. So I would take that dotted line that I just drew, move it to negative 4, so that it's going to cross over right there. And there's my final curve. So they didn't ask us to graph it, but let's answer their questions. Shifting horizontally, how many?
4.
To which way?
Left.
Vertically shrinking by a factor of,
Negative 3/4.
let's just say positive 3/4, because we've already handled the negative sign. We're going to handle it by reflecting across the x-axis. Okay, now one thing I notice here, notice that if you have a horizontal shift and a horizontal reflection, you can do them in either order. Doesn't matter. But if you have a vertical shift, let's take an example. Let's take square root function. Okay, this is y equals square root of x. Well, let's take y equal negative square root of x plus 3. Well, I know that that negative sign is a reflection across the x-axis. This plus 3 is a vertical shift. Well, notice if I did the plus 3 first, and then I reflect about the axis, there's my line. But if I do it in the proper order, I reflect about the axis first, and now I move it up 3, there's my line. So there's my true line, but there was the line I would have got had I done the shift in the wrong order. I'm sorry, if I'd have done the shift first and the reflection second. So when you're doing vertical shifts and horizontal reflections, order matters. You must do the shift first. The reflection first. Now, they aren't giving you any examples of that. Because of that, they're allowing this last step to be the reflection. Well, if there was a vertical shift added to this, if they would have had a plus 2, they couldn't have done it in this order. They would have had to do the reflection before they did the vertical shift. Okay? So the way to handle it, the way that you make sure you never make a mistake is to do your reflections first before you do anything else.
Okay.
Give the equation of the function whose graph is described. Okay, so we have f of x equals x squared minus 4x plus 3. Well, you'll notice that that factors into x minus 3 times x minus 1, which is a parabola. We know it's a parabola, right? Because it's a quadratic. Well, how do we graph? If we can get the quadratic in x-intercept format, which we have it in here, I know the x-intercepts are 1 and 3. So this parabola has to open up, so it must look like this. Doesn't go through the origin, but y is equal to 0 whenever x is 3 or x is 1. What would its vertex be? Well, that's its vertex. I don't know the y value at the moment. Well, yes, I do, because I know that is 2. So if I plug in 2 for x, I get 4 minus 8 plus 3, negative 1. So that's negative 1, that point. And that's positive 1, and that's positive 3. Okay, so if we horizontally shrink that by a factor of 1/4, does this parabola get narrower or fatter?
Fatter?
No. In other words, this is what I was originally referring to as a horizontal shrink by a factor of 4. So it gets narrower.
Okay.
By 1/4. So what does that mean? There's 2 units between those two intercepts. Well, that must mean there's only going to be a half a unit. If I'm going to shrink it by a factor of 4, this number is 2. And I now need it to be shrunk by a factor of 4, so the distance between my two intercepts is only going to be, instead of 2, it'll be a half. So that is 1 3/4 and 2 1/4. So this parabola now looks like this. Same vertex, because a horizontal shrink factor doesn't translate it left or right or move it up or down. It only changes the shape. And I know the shape is going to be 4 times skinnier. Would you look this one up, make sure I got it drawn right? Oh, they want the equation, excuse me. So we need the equation of that line. Wow. So that is x minus 1 3/4 times x minus 2 1/4. And when I multiply that together, I get x squared minus 1/2 x plus, what is 7/4 by 9/4, 63/16. Is that the equation? Are you able to look this one up, Morgan? Morgan, you still there? Offline. Go ahead and reboot and log back in. The meeting ID number again is 716-957-493. Hi again.
Hi, sorry about that.
That's all right. Can you look up the answer on this one, 53?
Yeah.
Not sure. Not sure I'm doing this right.
It's y equals 4x squared minus 16x plus 12. So then you would just multiply each factor by 4, right? Since it's shrinking, it'd be like not 1/4, but 4.
I'm trying to get a handle on why this is, how to do this. I'm not sure I know how to do this problem. I thought I had a complete understanding of this, but now I'm not so sure. Let's see, minus b would be 16 over 8, so you have the same vertex. And when x is 2, you have 16 minus 16. When x is 2, that's 16 minus 32 minus 16 plus 12 minus 4 instead of minus 1. They're saying that parabola actually goes deeper like that.
Mm-hmm.
So it changes the y point on the vertex when it shrinks? See, that wasn't my understanding. I didn't think that it changed the vertex of a parabola when you horizontally shrunk it. Although now that I think about it, no.
Yeah, because it would make it like, since horizontal is up and down, right? It would like.
That's a vertical adjustment there. In other words, if I graph this, what is that?
Oh, yeah.
That's 2x plus or minus 4 times 2x minus 3. 8 and 6, no? It isn't that. Huh. I'm going to have to think about this a little bit more. This is because I've been tutoring translations and shifts and things for a long time, and this is the first time I've encountered having to come up with the equation when you shrink it by a factor of 4. Well, I'll look at this and we can address this more at your appointment tomorrow. We still meeting tomorrow?
Yes.
Okay.
You want to just go to 56?
Let's go to 55.
Okay.
Because I'm sure of 55. 53 and 54 I want to give some more thought to before I tell you what I think. Because I'm obviously not right on 53. So the cube root of x, again, is much like the square root of x, only it goes positive and negative. So this is y equal x to the 1/3. And it's shifted 2.3 units to the left. This graph is then vertically stretched by a factor of 7.8. Finally, the graph is reflected across the x-axis. Okay, so this equation shouldn't be too hard to come up with. How do I handle the 2.3 unit shift to the left?
Do you add 2.3 units?
To where? What's the equation going to look like?
Oh, the cube root of x plus 2.3.
Inside the radical or outside?
Is it inside?
Yeah, because the horizontal shifts are inside the function, Vertical shifts are outside the function. If this 2.3 was out here, that would be a vertical shift. It wouldn't be a horizontal shift.
Right.
Okay? So that takes care of the 2.3 unit shift to the left. Then the graph is vertically stretched by a factor of 7.8. What do I need to do there? Does the 7.8 go in front of the x, or does the 7.8 go in front of the radical sign?
Is it with the x?
No. Vertical stretches, shrinks, and shifts are all outside the function. In other words, this is the function. Whoops. There's the function, okay? So if I want a vertical stretch of 7.8, I have to do 7.8 times f of x. I don't do f of 7.8 times x. This would be horizontal stretching and shifting. This is outside the function. That's vertical stretching or shift or shrinking. So to do a vertical stretch, I got to put my 7.8 outside the radical sign.
Okay.
And then to do a reflection across the x-axis,
Do you make the 7.8 a negative?
yes.
Okay.
In other words, when you're reflecting across the x-axis, the negative sign is outside the function. It's that. It's not f of negative x. If it's f of negative x, that's a reflection across the y-axis. Okay, so 55 is relatively easy. I'm sure of that answer. It's this horizontal stretch and shrink that's got me a little puzzled.
Yeah, same.
I thought I understood it perfectly, but now I'm okay. Have you had trig? You get trig next semester?
I don't know how we I don't know if it's like semester by semester or.
Okay. It's actually easier to talk about this with the sinusoid function, which has all of these vertical, horizontal stretches, shrinks, shifts, reflections in it also. But it's easier to see if you're looking at the sine curve instead of some of these other functions. All right, so what's a mathematical expression? A salary after a 4.4% increase. If the original salary is X, what's the new salary?
Is it just 4.4 times x?
If you had a job and you earned $10 an hour, and you got an increase of 4%, not, we'll make it more complicated, 4.4%. Let's say your salary was $100, and it increased by 4%, what would it be? Just 4%.
Like 104 or something?
Right. It's only going to increase by $4. If you take 4% of 100, it's 4. And then you add it, so your salary is now 104. Well, if it increased by 4.4%, then your salary is 104.4. But if we let it be X instead of 100, now what is it?
Is it X plus 0.044? Or times?
Yes, okay. Times X. In other words, there's two ways to write it. That's my original salary, plus I get this much more of that. So that's the new expression, but I can combine that because I have X terms. So that's 1.044X. This is the answer they're going to have in the book.
Wait, because you're adding one, okay.
I'm adding 1X and 0.044X.
Okay.
Okay. I can't go too much longer after noon because I have another session coming up here that the library will
Okay, yeah, that's
get to.
fine.
Let's do one more. 57. Whoops, hold on. The total cost of $20,000 plus $655 for each item produced. And X is the number of items produced. So if we let X be number of items produced, what's the mathematical expression for this?
Is it 20,000 plus 655x?
Yep. That's your cost.
Okay. Okay.
All right. Let's pick up next time with 58 and hopefully 53 and 54.
Okay. Sounds good.
All right, Morgan. I'll talk to you tomorrow.
Okay.
I think it's tomorrow, isn't it?
Tomorrow's at 5:30, right?
Let me just check real quick before we hang up. Yep, 5:30.
Okay. Sounds good.
All right, bye-bye.
Okay. Bye.